Get everything. Well, let's talk about number 10 first. What does this mean?
Absolute value.
Well, what is that sentence? What does that inequality mean? It means two different things.
The absolute value of x minus 2 is greater than 10.
Well, it means x minus 2 is greater than 10. That's the first thing it means. Or x minus 2, and for the second case I got to switch the sign and the direction. See?
Yeah.
In other words, it's a little harder than equations. In equations, the second part is just it's equal to the negative 10. But in this one, I need to change the direction of the sign, the inequality sign, additionally. But notice what I never change is what's inside the absolute value sign. In other words, that's always x minus 2. It's either x minus 2. The first part is exactly the same as what you're looking at without the absolute value signs. The second part is the inside opposite sign, or I should say opposite direction and opposite sign. And now if you solve each of those, you get two different answers. You get x is greater than 12 or x is less than minus 8. So you almost always have two answers. Sometimes you don't have any answers. I had a 7th grader get me caught up once because he gave me this problem. Put a negative sign over here. And I tried to solve it. I didn't recognize that that's impossible. But hold on, less than. It would be impossible for that to be less than minus 10. So if you get a problem like that, the very first thing you have to realize is that there's no solution. It's impossible. If you proceed with the two statements that I made, you'll come up with an answer and it won't be real. I mean, it won't be the right answer. So if we go back to your problem, this one here, let me blow it up. Let me take a picture of it so that I can write on it. So what do these two statements mean? Or what does this inequality mean? And usually I'm going to separate them horizontally with an or, because I'm going to have to solve each one vertically. You know what I'm saying?
Mm-hmm.
Okay, so what's this mean?
4 minus x is greater than or equal to 3.
Or
4 minus x is less than or greater than negative 3.
and then it's just a simple matter to solve both of those. Let's go ahead and solve the left side. Let's make sure you know how to handle that. How do I solve the left side? In other words, this part.
You subtract 4.
Okay, so then I got minus x is greater than or equal to minus 1. Now what? In other words, you want x all by itself without that negative sign. So I got to divide both sides by negative 1. And whenever you multiply or divide by a negative number, you switch the direction. So that's what the solution of the left part is. Solve the right part for me.
So subtract 4.
giving me? Just give me each line.
-7.
Okay.
And then x is greater than or equal to 7.
Okay. And it says show it on a number line. Well, if I draw a number line and I put my key points, 1 and 7, don't really need to put any other points on that number line. I don't need 0. My 1 and my 7 identify where I'm at on the number line. So, what goes on the 1? A closed dot or an open dot?
Closed.
Which way does the line go? To the left or the right?
To the
It's less than.
left.
So it's, in other words, it's based on that right there. It's less than or equal to 1. And then if I go over to 7, again, a closed dot, because it's greater than or equal. Which way do I go?
To the right.
That's how you graph it on a number line. The only thing you really need to know is whether it's an open dot or a closed dot, and that's based on whether it's greater than or equal or not. Okay, let's do the same exact process on the next problem. Tell me the two things this means.
10 minus 3x is greater than 2, and 10 minus 3.
Less than 2. Or
10 minus 3x is greater than -2.
okay. Do we need to go through the solution, or are you good with the solution of each of these?
Go through it.
Okay. The next step on the left-hand side of this inequality.
That was the track time.
So give me the next row. In other words, tell me what the next line is what I really mean.
-3x is less than -8.
And the next line.
X is less than or greater than 8/3.
Good. And then over here on the right side, solve that.
-3x is greater than -12. And then x is less than 4.
And again, on a number line, if I put both points, there's 8/3, there's 4. Where's my answer going to lie?
In between.
With circles on both ends. Like that. Okay. Talk about the next one. These are a little tricky. When you have first thing you want to do on these, same thing you would want to do if it was an equation. Turn it into a quadratic equals 0. Or in this case, it's going to be turned into the following quadratic. Less than 0. How's that factor?
-10 plus 2, so x minus 10 plus 2.
Yeah, now, whenever you have the product of two variables is less than 0 or greater than 0, or the quotient of two variables is less than or greater than 0, there's a particular method that you use to solve it, and it's called a line chart. And first of all, you identify what your critical points are. And your critical points are anything that makes either term equal to 0. So 10 and minus 2 are my critical points. Or if I had an expression like this, it would still be 10 and minus 2 would be my critical points. Now, what I do with those critical points is I graph them. Again, I don't put 0 on there. Now, what we're going to do next is a method where we pick any number to the left of minus 2. Pick a number to the left of minus 2. Make it as small as possible.
-3.
Okay. When x is -3, what's the sign on this term on the left? Pointing at x minus 10. What's the sign of that become?
-13.
I don't need the numbers, all I need is the sign. You'll see why. What's the sign on the right term become?
Negative.
Negative times a negative is a positive. What that tells us is that any value I use to the left of -2 is going to give me a positive answer for this quadratic. Now let's pick a number between -2 and 10. Nice simple one.
5.
Okay, or 0, but either one is fine. When you use 5, what's this term on the left? Is it plus or minus?
Negative.
And the term on the right is positive. Multiply those two together, you get a negative. And what that tells you is that every number between -2 and 10 would give you a negative answer. Now finally pick a number to the right of 10.
11.
That would give you plus, which is also plus. Now we have our answer. If we look at the line chart, they want to know where that thing is less than 0. Well, it's right there. That's the only place where it's negative. If they wanted to know where it was greater than 0, it would be all of this area plus all of this area. And that's how you do when you have a quadratic inequality with 0 on one side. Let's do the same technique on this second one. Tell me what the next line's going to be.
I'm 2x squared minus 7x minus 4 is greater than 0.
Factor that. I'm assuming it factors, and which means it's got to be 2x and x.
2x plus 1, x minus 1.
Well, it's definitely plus 1, but it's minus 4. Remember, the signs have to be opposite, and I got to produce a minus 7x in the middle. And I only do it with this combination. In other words, I check, that's plus x. Excuse me, I got it. Yeah, no, that's right. And that's minus 8x. Add those together, you get minus 7x. That's our proper middle term. We've done it properly. Now, what's the next step?
To find the
critical points. I don't know if that term is universal, but that's what I call them. What are they here?
-1/2 and 4.
Now what do I do?
You put them on a number line.
Now what do I do?
And take a number that's lower than 1/2.
Okay, give me a number.
-1.
Okay. What's the left term when you use -1/2? 1.
Negative.
It's the right term.
Negative.
So what does that tell me?
The answer still up to negative.
Means that everything to the left is positive. In other words, here's what I'm solving. Let me erase that just because I need room. That whole thing's got to be greater than 0. So when I know that term's negative and that term's negative, that means whenever I multiply those two together, I'm going to get a positive. Now, pick a number between negative 1/2 and 4. Nicholas? Did I lose my audio? Nicholas, you still there? You still there, Nicholas? I can't hear you. You apparently can hear me. Make sure your microphone in the upper left did not accidentally get muted. I'm going to call you. There you are. There you are. Did you somehow accidentally get that thing muted?
I think so.
Alright. Alright, so let's see. Where were we? We were at the critical points being negative 1/2, comma 4, and which meant that we had x 2x plus 1 times x minus 4, and all of that had to be greater than 0, minus 1/2, 4. When it was left, that was negative, which made that positive. What about it when it's in the middle? Pick a number for x.
0.
What's that give me?
Positive and
Positive and negative, which multiplies together to be negative. Now pick a number to the right of 4.
5.
Positives. And there you have your answer. Now I just looked at that. It's got to be greater than 0, so those are my answers, and these are my answers. Now, these do not always alternate. I actually had a student tell me once that their teacher told them that, yeah, once you get the first term, you're done because they always alternate, and they don't. I have definitely come across equations where they don't always alternate. So you kind of have to test each one. On to logs.
Yep.
Okay. How are you with logs?
I'm pretty good.
Okay. Expand that first one for me. Just expand.
Log of 4 plus log of gosh.
Do it step by step. I prefer it that way.
Log base, or x to the third.
Okay.
Minus log y to the fifth.
Now do the next step below that. That's log of 4. What's this middle term become?
3 log of x. Minus 5 log of y.
Okay. Next one. How am I going to do it? The first thing I'm going to do.
In
other words, just like calculus, logarithms doesn't really like radical signs. They're not terribly helpful. So always change your radical sign to a fractional exponent. So how would I write this?
log base 4 of 9
times so now expand that.
log base 4 of 9 plus log base 4 of x, or 1/5 log 4 of x, plus log, or 1/5 log of yeah.
Like that. Yeah, no, you, once I see that you know how to do it, it's fine if you want to do it in one step. I don't need you to do it in 2 steps. Okay? Now let's expand the third one. Number C.
Log base of 6.
Actually, it's not log base 6. It's common log.
Alright.
So it's log base 10, which means I don't write anything. So it's just log of 6.
Yeah, I just used to saying that sometimes.
Okay.
Plus 2 log of x. Plus 5 log of y.
Solve the following equations. Let me scroll up a little bit here so I get more work or more screen to work with. So what's the first step here?
To subtract 1.
And then what am I going to do?
Divide by 2.
So I end up with, and this is key because I want to isolate this. I want to get this down to that. So that's equal to that. Now, just like inequalities, this is equal to 2 things. What 2 things does it mean?
X minus 5 is equal to 6, and x minus 5 is equal to -6.
Yep, these are a little easier because you only have to change one thing on the other side. You don't have to change a sign or a direction of the inequality. So here you get x equal 11 or x equal -1. Okay, over here on the right, that is an exponential equation. And by that I mean the variable's in the exponent. It's not on the algebra line. So typically you don't have algebra to solve this. In other words, if I told you that 2 to the x equals 7, could you solve that with algebra?
No.
No, it'd be impossible. You wouldn't have any, you might, by trial and error, you know, after about a day and a half, you might come up with a value for x that was close, but you wouldn't come up with the exact value. That's because it's not an algebraic equation. It's an exponential one, and you actually need to use logs to solve that. So typically, most of the time, when you have exponential equations, you got to use logs to solve them. Every now and then they will give you one where there is a common exponential base and you won't have to use logs to solve them. And this is one. What is the common exponential base between the two numbers 32 and 8?
2.
Write 32 for me in terms of 2.
Add 2 to the power of 6 times 2x minus 1.
And very important to use parentheses. Is that 2x minus 1? Okay.
Yeah.
In other words, if I don't use parentheses, I get a different answer. And over here, I'm going to call it 2 to the third in parentheses. And that's 4x plus 1. Now what's the next step?
To make the to the powers equal to each other.
Well, first of all, I got to use the rules of exponents. So I got to multiply these exponents. That's very important. So that becomes 12x minus 6, and that becomes what? 2 to the
12x minus or plus 3.
Okay, and now, ooh, we make a mistake somewhere?
Or sorry, it's plus 9.
It's 2 to the 5th, I think, is 32. First of all, do you see the problem? The way I did it, now I'm going to equate the exponents. The 12x's are going to cancel, and I'm going to have minus 6 equals 3, which would suggest there is no solution. And when you get an answer like that, my first instinct is I made a math error somewhere. So I go back, and did I represent 32 properly? Well, no, I didn't. It's not 2 to the 6th, it's 2 to the 5th. That's going to matter, because now that's going to be 10x minus 5. And now, I go over here on the left, because I have some writing.
It should be 12x plus 9. Or, yeah, no, sorry, 3. Yeah, 9.
I think it's 3. In other words, I'm multiplying 3 times that expression.
Yeah, I know, but,
Oh, after you...
It's a little blurry, but it's supposed to say 4x plus 3 to the power of it.
Oh, okay. Then it is. Okay. And now because I got the same base, now I can equate the exponents, and I trust you can solve that easily.
Yeah.
Gives you x equals minus 7. In other words, we were able to solve this without logs, only because we had both numbers had a common exponential base. And you figured it out, it's not a common factor. In other words, 8 is a common factor, but it's not a common exponential base. 2 is the only number that is a common exponential base to the number 32 and to the number 8. In other words, if I make that a 7, can't solve the problem with this technique and have to use logarithms. But the fact that they gave us a number that had common exponential bases, we can solve it without logs. Now, that was the middle one, right?
Yeah.
Which one next? Should we... Let me see if
The right one.
The right one? Okay. At the top?
Yep.
You don't need to start at the top. Let's start where you need to start, but in other words, if you know how to do these, we shouldn't start there. Rewrite in graphing form, state the vertex and axis of symmetry. How am I going to write that? Well, first of all, what's good graphing form? What's the general format for graphing for a quadratic? Y equals what?
A times x minus h to the squared, plus k.
So if I can put this thing in this format, then I'll be staring at the vertex, because the vertex is h comma k. And I'll also be staring at the axis of symmetry, which is x equal h. So that's almost always the way to go when you have a quadratic that's in standard form, is complete the square. Okay? Well, what's my process for completing the square here?
Y equals x squared minus 8x.
So I'm going to put parentheses around that. And I'm going to set the 3 aside for a moment. And then what am I going to do? Well, here, let me rewrite it. Here's how I want to write it. X squared minus 8x. And I'm going to leave room to complete the square and put my plus 3 there. So at this point, I have not changed it. And that's the key on all of these kind of problems. Make sure when you go from step to step, you do not change anything. So what's the complete the square process involved?
Like what to do next, or?
Yeah. What am I going to do next?
Take half of 8 and square it.
Good. What do you get?
16.
And it's always a plus, because notice that even if it's a negative number, once I square it, it turns plus. So I'm always adding in that spot. And now, because I just changed the equation, I got to balance it by subtracting the same number I wrote in. Now, this line is still the same as I started with. And every step of the way, you should kind of be checking to make sure you're not changing it. Now, how can I write it? In other words, because I completed the square, I can always write that as a linear term. In other words, as an x minus h squared. What is it that goes in there?
X minus 4.
Yeah, whatever you got when you took half that middle term. That's what goes in there. Combine those two numbers. Now I have it in perfect graphing form. Really not, I don't like the fact they said graphing form, because there's 3 different forms you could put it in that would somebody be able to graph it. What they really meant was vertex form. Because when it's in vertex form, then it's really easy to graph. Tell me how to graph that. Where do I start?
The vertex, which is 4, negative 13.
So the vertex, I lost my pen. Hold on a second. Let me see if I can figure out how to solve this without doing it. It's happening to me regularly. Does that solve it immediately? I think it did. So the vertex is at 4, negative 13. No, it didn't solve it. So I'll bet if I close that, minus 4, 13. Hold on. No. Let me try this one more time. Close it out. Reopen it. Things have slowed down. This has been happening lately. I don't know why. Now it'll work fine. Yeah. Don't know what's going on there. So what do we get? We got y equal x minus 4 squared minus 13. So my vertex goes at 4 comma minus 13. Does it open up or down?
Up.
So I'm looking at a parabola that basically looks like that. Now, when they have you graph it, they didn't say graph it. They just said state the vertex and the axis of symmetry. Where's the axis of symmetry?
At x equals 4.
Good. It's always a line. It's not a point. All right. Let's do number B in a similar fashion. I'll get you started. What's the next line?
Y equals x squared plus 10x plus 25. Minus 4.
Minus 25. In other words, whatever you write in there, you got to balance it out. If you're on the same side of the equation, you balance it out with the opposite of the number. If you're going to balance it out on the other side of the equation, you balance it out by adding the same number. And finally, what does that go into?
Y equals x plus 5 squared minus 29.
What's the vertex? Where's it at?
Negative 5, negative 29.
And the axis of symmetry?
X equals negative 5.
Okay. Now, some of these are a little harder. If you have to, in other words, both of them that we've done, the x squared term had a coefficient of 1. And that always makes it a little easier. When the coefficient is not 1, the first thing you have to do is factor it out. So give me the next line here on C.
Y equals 2 times x squared minus 6x. And then go outside of the parentheses plus 3.
Good. Complete the square.
It's plus 9.
Balance it out.
Minus, alright, y equals 2x.
Hold on. Balance it out. In other words, when I wrote plus, I can't just arbitrarily write plus 9 in there. I got to balance it out.
Subtract 18.
Exactly. That's what I was trying to get at. You don't subtract 9, you subtract 18. Because when I wrote 9 in there, I added 18 to the right side of the equation. It's always whatever you write in there times whatever number was factored out. So now, give it to me in vertex format.
Y equals 2. X minus 3 squared minus 5.
Minus 15.
Oh yeah, sorry.
Vertex is at
3 negative 15.
line of symmetry.
X equals 3.
Okay. I'm going to have to do the same thing on this because I got a coefficient. And it doesn't matter if that were a factor. In other words, let's call that 26x. Okay? Well, the first line is going to be 3 times x squared minus 26 divided by 3x plus 10. In other words, this number does not have to be a greatest common factor. It just has to be factored out, regardless, whether it divides into that coefficient or not evenly.
26 should be 27.
What's that?
26 should be 27.
No, I'm saying, well, as long as it's 27, then when I divide by 3, it's going to be 9, and I'll have a whole number there. And I know you know how to do that one. We just did one like that. What I'm trying to say is that even if this coefficient were 26, I would still have to factor the 3 out, like I've done. In other words, what I have written is exactly what I've written there. It's the same equation. Only now I can complete the square by taking half of that number, squaring it, balancing it out. Now I'll have it in vertex format. So my point is that when you have to get rid of that coefficient, you factor it out whether it factors evenly or not. But you're right, this is going to be 3 times x squared minus 9x plus 10. It's easy when it divides evenly. It's harder when it doesn't divide evenly. And you might not notice it because you're not really taking a greatest common factor. And it kind of looks like you are. In other words, when I do this problem, it looks like I've taken a greatest common factor. But I'm not really. I'm just dividing by whatever that number is. Doesn't have to be a greatest common factor at all. And the way, okay, so how am I going to complete the square here?
Half 9 and square it.
Which is?
20.25.
You know what? Leave it in a ratio format. In other words, it's 9 halves, which becomes 81/4. It's the same as your decimal. It's just, I think ratio answers are always better than decimal answers. Now, what do I have to balance it out with? Well, I just added 3 times 81/4. So I got to subtract 3 times 81/4. Like that. That's my K when I'm all said and done. And the rest of it is 3 times x minus 9 halves squared minus that number that is circled over there. Let's take number 17A. They're good. These are tough. These are tougher than the stuff we've been working with in the CPM. It's my first step in A. Find all roots by factoring. So factor that. Greatest common factor. Always start there.
There's none.
What's that? There's no number, but there's a variable that you can pull out. What is it?
X.
What's left?
16, x to the 4th minus 81.
So now, what do I say next?
In
other words, either x has to be 0 or that thing has to be 0. That's what I would say next. However, I really haven't finished fully factoring it. Notice what I have on the right is difference of perfect squares. How's that factor?
I have 4x squared minus 9 and 4x squared plus 9.
Now, I again have difference of perfect squares. Factor that again. The one in the middle only. The one on the right side doesn't factor. There is no sum of squares. But this is perfect squares. How's that factor?
2x minus 3 and 2x plus 3.
This stays as 4x squared plus 9, and all of that's equal to 0. So what are my solutions to start with? Find all roots. What are they?
X equals 0. 3/2, -3/2.
And then finally, we got to find the root of that. So if I say 4x squared plus 9 equals 0, that means 4x squared equals minus 9. That means x squared equals minus 9/4. What's x equal?
The square root of 9, or -9/4.
Well, first of all, it's plus or minus, because whenever you solve an equation by taking the square root of both sides, always begin your answer with the words plus or minus. And the square root of minus 9/4 is square root of 3, it's 3/2, but it's a minus, so it's 3/2 I. In other words, here's how I do that. I got the square root of minus 9/4. It's the square root of minus 1 times the square root of 9/4, correct?
Yeah.
Always my first step is to take out the I. Then there's no confusion at all. That's I. And the square root of 9/4 is 3/2. So it's 3/2 I, but it's plus or minus 3/2 I. So you have 5 solutions. You have these 3 that are real, and then you have these 2 that are imaginary. And if you forgot to put the plus or minus in there, and you only get 3/2 I, always remember that imaginary solutions only come in pairs, never by themselves, never isolated. If you have one imaginary solution, you'll always have another solution that is the conjugate of your first solution. In other words, if 2 plus I is a solution, then 2 minus I is also a solution. So if you forgot the plus or minus and you just get that, then you're going to be staring at a single solution. You're going to say, how come I don't have 2 solutions? So remember that plus or minus gives you the both solutions you're looking for. All right, 17b. Again, cubics are incredibly difficult to factor. Who knew? But they are. There's no, you know how we have a quadratic formula. If you have a quadratic, no matter whether you can factor it or not, you can always find the roots by the quadratic formula. There's no such thing as a cubic formula. So when you have a cubic, you haven't learned it yet, but there's really a complicated technique for factoring, finding the zeros, unless something is true. And that something is, if it can be grouped, then there's an easy way to do it. And by grouping, the reason a cubic can be solved by grouping is if the first 2 coefficients are in the same ratio as the last 2 coefficients. Well, the first 2 coefficients are 1 and minus 7. Is that the same ratio as 4 is the minus 28? And the answer is yes. So as long as those coefficients are the same fraction, the same ratio, then you can group it. And how do I group it? Put parentheses around those, put parentheses around those, and now do some greatest common factoring. What can I pull out of the left term?
X squared.
What's left?
X minus 7.
They're being added. What can I pull out of the right term?
4.
What's left?
X minus 7.
Now, if you've done it correctly, this binomial term will always be equal to this binomial term. And what you do next is to factor out that binomial term. It's not something you do very often in math. In fact, the first place you ever run into it is when you get to cubics and they start teaching you about grouping. But I can pull out an x minus 7. What's left?
X squared plus 4.
And there's your answer. Well, not quite your answer. They want all zeros. So what are my zeros?
X minus 2, X plus 2,
No,
X minus 2.
no. That is a quadratic that only has imaginary solutions. Notice that one of my solutions is x equals 7, right? The next solution I'm going to get by setting that equal to 0, which makes x squared equal to negative 4, which makes x equal to what? Plus or minus. In other words, I am solving an equation by taking the square root of both sides. I'm always going to begin my answer with the words plus or minus. And now what's the 2i? The square root of negative 4 is the square root of negative 1 times the square root of 4, which is I times 2. So that's how I get it. Goodness. Yeah, let me do this. Probably just going to have time to do 18. Oh. I've been going left to right. I realize I've been jumping big numbers. It goes 1848, but if I go down, that wouldn't happen.
I think she just typed it wrong.
Oh, did she?
Probably.
What happens if I scroll? Oops, hold on. Yeah, you're right. That's the first time she's put a number next to another one. All right. For this one, we need the binomial expansion theorem, which basically is what is a plus b to the nth power going to be equal to. And this, you just kind of have to memorize it. It's n choose 0 times a to the nth times b to the 0th, which is just 1, but it helps keep track of it, plus n choose 1 times a to the n minus 1 times b to the 1 plus n choose 2 times a to the n minus 2 times b to the 2 dot 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 all the way up until you get n choose n, depending on what n is, and then you got a to the 0th, the last term, and that's b to the n. Okay? So, the way I'm going to expand 2x minus 5 to the 9th is by using this. And they want the third term. That's the third term. So rather than expand it all out, let's write that term in terms of this problem. So how would I write my n choose 2?
I choose 2.
What's the rest of it? A to the, not A, because A is 2x. So I'm going to substitute 2x for A. What's its power?
To the 7th.
B is minus 5. What's its power?
2.
So there's my third term. And you could almost give that as an answer. We can simplify it a little bit. It's 25. And what's 9 choose 2 equal to? If
36.
you want a real number, if she accepts combinations as answers, you wouldn't need to give it. But what's 9 choose 2?
36.
So it's 25 times 36 times what?
128 to the 128x to the 7th.
Cool. And then you might want to multiply those three numbers together. So your final answer is some number times x to the 7th. That's it. That's how you do a binomial expansion. Now, the next one, rather than have me erase everything, can you tell me what the next one says? If you're looking at it.
We find the coefficient of x to the 6th and the expansion of 1 minus 2x to the 15th.
1 minus 2x to the 15th?
Yeah.
That's what it is?
Mm-hmm.
Okay. So if I'm looking for the coefficient of the x to the 6th term, well, my x term is b. So I'd be looking for the coefficients when it's b to the 6th, right? So what's that coefficient going to be? Without me writing it entirely out, what's the end part going to be?
Um, 15 choose 6.
Now that'll actually give me the 6th, well that would actually give me the 7th term. Notice that that's the first coefficient, the second. So if I want the 6th, I want n choose 5, first of all. And that's going to give me the 6th term so that the a term is to the 6th power. Well, they want the x term. So I need the b term to be to the 6th power. So it would have to be n choose 9 times 1 to the n minus 9 times b, which is minus 2x to the 6th. Do you see how I get that for my 6th term? Hold on. Actually, I'm not looking for my 6th term. I'm looking for my term where x has an exponent to the 6th power. That's actually going to be the term where a is to the 9th power, or to the 15 minus 9. I mean 15 minus 6. What do I mean? Let me think about this for a second. It's a to the nth, a to the n minus that. So in this case, it's a to the 15 minus 9, so that's 6. Yeah, that's not correct. That's got to be that, so that it ends up being that. So, in other words, what I'm saying is that the term where x is going to have an exponential of 6 is this term. And you'll notice that this number and that number always add up to n. N minus 1 adds to 1 to n. So does n minus 2 adds to 2 to n. So I know that 9 and 6 have to add to 15. And I know that these two numbers always add to 15 also, or whatever the top number is. So I think I have it right. Without writing the entire sequence out, you gotta be able to recognize some of these patterns. And now the answer is, well, you got to come up with that number. 1 to the 9th is 1, but then minus 2 to the 6th power is 64. So the answer to her question is 15 choose 6 times 64. Whatever that number gives you is the answer to 48. That's the coefficient of x. And unfortunately, I'm running late. I'm 3 minutes late for my next session, Nicholas, so I got to run. Make a note of, well, I'll remember where we left off if we come back to the same thing. But I will talk to you next time.
Okay, goodbye.